the method of solving a quadratic equation by completing the square. It's useful sometimes, but it's not very practical because sometimes it just takes a long time to solve using this method. But this method is used to develop the quadratic formula. So we'll do an example, and then we'll develop the quadratic formula using those ideas. Okay, so the idea is to write this quadratic equation, to write it in that vertex form. So what I want to do is to pull out, here's my x squared term and my x term. Maybe if I add in a number, that will make these three terms, x squared plus 6x plus some number, into a perfect square. So it's going to look something like this. X squared plus 6x plus some number to turn this expression into some quantity squared. And whatever you do to one side of the equation, you should do to the other. So that'll be equal to 16 plus whatever that number is. Now the number that we're going to use is going to be half of the middle term. So 6 over 2, and it'll be squared. So 6 over 2 is 3. Square it, you get 9. So I'm going to just, first I'll write that number down, and then I'm going to show you why it works. Okay? So if I write down this magic number, if I add in the left and the right hand side, this magic number 3, which is half of the middle term squared, then what happens is this side factors as x plus 3 quantity squared. Let me just check that over here, okay? X plus 3 squared, that'll be x plus 3 times x plus 3. So that'll be x squared plus 3x plus 3x plus 3 squared, which is 9. 3 times 3 is 9. Okay, and then you add these two terms together because they're the same thing. You just get twice the 3x. So this will be x squared plus 6x plus 9. Okay, so now going backwards, 6x is 3x plus 3x, so that's twice that special number 3 times x. Okay, and notice that I had to add in the 9, which was 3 times 3. So if this middle term was a 6, divide it by 2 to see what those two numbers are, and then square it to see what this number has to be. That's how I do middle term, divide by 2, square to get that special number to add in. Okay, now that I have that, the left-hand side is written as x plus 3 squared. And the right-hand side, well, 16 plus 9, I guess that's 25, right? All right. And now that it is written in this way, I can go ahead and use the square root method. Square root both sides. You get x plus 3 equals plus or minus the square root of 25, which is 5. There's your two equations, x plus 3 equals 5, or x plus 3 equals negative 5. Subtracting 3 from both sides, I get x equals 2, or subtracting 3 from both sides, x equals negative 8. Okay, so again, this was completing the square. What you do is you're going to add to both sides half of the middle term squared. And the way we use this method is you're going to want to get both of the x terms to one side and the number parts to the other. So here I have x squared plus 6x. So if the 6x was on this side, we'd have to like move it over to that side. So the terms that involve an x or your variable on one side and all the numerical terms on the other. Okay, now what I want to do is use this method to figure out how do you solve something that's generally of the form ax squared plus bx plus c equals 0. Okay, so first what we're going to do is we're going to put the equation into that standard form by getting the x squared term and the x term by itself on one side. So I have ax squared plus bx, and then subtract c from both sides. So equals negative c. Also, I don't like this coefficient in front of the x squared, so I'll just divide both sides by it. So I get x squared plus b over ax equals negative c over a. Okay, now I remember that I want to add in some special term. So I got x squared plus b over ax plus some special number is going to be equal to, got to add it on the other side too, some special number minus c over a. Okay, so what is that special number? It'll be half of the middle term, so that'll be b over 2a, half of the middle coefficient squared. So that'll be b squared over 2a quantity squared, which is 4a squared. So that's what I want to add into both sides. Okay, on the left, that turns this into a perfect square. This becomes x plus b over 2a quantity squared equals, and on the right-hand side, I actually have these two numbers, and I'd rather combine them together. They're both fractions. I need a common denominator. So if I multiply a by 4a, I'll get 4a squared here. So let me just multiply both the top and the bottom by 4a. And now the denominators are both 4a squared. So I can put that all over 4a squared. And the numerator becomes b squared minus c times 4a, which is 4ac. So now this should start looking familiar. If I square root both sides, I get x plus b over 2a is equal to plus or minus the square root of this thing. So the numerator will be the square root of b squared minus 4ac. And the denominator, the square root of 4a squared, well, that's just 2a. Okay, now we're almost done. All I'm going to do now is subtract b over 2a from both sides. And what I get is x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And this is a quadratic formula. Actually, a lot of us see this written as a single fraction, as x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So here's where the quadratic formula comes from. We're just really going to focus on how to use it, but I think it's pretty easy to see that it comes from completing the square. Now let's talk about how to use it. So generally, if you have a quadratic equation written in standard form like this, all terms on one side, 0 on the other, ax squared plus bx plus c. So you have to know that a is the number part of the x squared term, b is the number part or coefficient of the x term, and c is the constant term. Then you can compute x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Do this computation. Now this part of the computation here, the square root of b squared minus 4ac, this computation, that's called the discriminant. We look at it first, like lots of times when I do this computation, first I'll compute b squared minus 4ac, and then after I make a decision, then I'll go ahead with the rest of the computation. And here is how the decision works. If b squared minus 4ac is positive, then you're taking the square root of a positive number, which you are allowed to do. It's going to be a real number. So you're going to have two real solutions. If this quantity, the discriminant underneath the radical symbol, is 0, then, well, the square root of 0 is just 0. And to say plus or minus 0, like, it's the same thing. So there's not two equations. It's really just one equation. You get one real solution, and that solution is going to be just negative b over 2a. And then if b squared minus 4ac is negative, then that means you have a negative number underneath the square root symbol. And we know that the square root of something negative will be complex. So you're going to have two complex solutions. So these are the three cases of types of solutions that you'll get with quadratic equations. All right, the next video is going to focus on how to use the quadratic formula.